Today we're going to talk about hyperbola, which is the fourth and the final of the four conic sections. So just to kind of review what we've covered, first off, a parabola, what shape does that make?
U.
It's a U. Remember that we can have them open up, sometimes they open down, and occasionally they do this weird sideways one, where they go this way or that way. This comes any time that you have your x and your y and only one of them is squared. So you have like y equals x squared or negative x squared, and then you have like x equals y squared. And you could have other stuff over here too. Something like that. So that's a parabola and there's a sideways parabola. Those equations have your x and your y, only one being squared. Here the x is squared, here the y squared. Now a circle, you know what a circle looks like. Circle. A circle equation has x squared and y squared, usually on the same side, and it equals r squared. So that's a circle with what radius?
6.
6. Remember that this was r squared, so this was radius 6. All right, ellipse.
An oval like.
Yeah, it's a lot like a circle except for you stretch it like this or like this. It could be sideways oval or an up and down oval. It also has x squared and y squared though. Circle has x squared and y squared. Ellipse has x squared, y squared.
Equals 1.
It always equals 1, and then there's numbers underneath. You know, if you get it in the right form, you have numbers underneath. Those numbers kind of tell you whether you're going to stretch it more this way or you're going to stretch it more this way.
Stretch it upwards.
Yeah, this one, since there's a 25, which is bigger, under the y, you would stretch it. So it would be more like this one right here. Now the hyperbola, it's going to be the third one in a row where you have x squared and y squared.
It's like two parabolas.
Yeah, they'll either go like this, like almost like opposite facing parabolas, or they'll go like up and down. And it's a hyperbola.
Like x minus y squared.
Yeah, and the difference is they have x squared and y squared, but one of them is negative. So you'll either say x squared minus y squared,
Y squared minus x squared.
yeah, and you'll have it equal 1, or you'll say y squared minus x squared equals 1. And then just like an ellipse, you'll have numbers under these, like 16, 25, 1, and 4, something like that. So here's your four shapes. The biggest thing to know is if only one of your letters is squared, it's definitely a parabola. If both letters are squared, we're looking at circle, ellipse, hyperbola. It's only going to be a hyperbola if what happens?
If it has a negative and it equals to
Yeah.
1.
If it has the minus in it. It's the only way you get a hyperbola. If you have them both being x squared and y squared and they're both positive, you're looking at a circle and ellipse. And we've kind of talked about the difference between those two. Okay, so if you have x squared minus y squared, that makes a certain kind. X squared minus y squared, that's your sideways. And then if you go y squared first, and you got y squared minus x squared,
Up and down.
yeah, it's up and down. So a lot of times you're doing a standardized test, and you're going, what hyperbola is it? Well, if it's y squared minus x squared, you're going up and down. X squared minus y squared, you're going left and right. So let's look at our first example, which we had. You might just have to tell it to me. I had x squared. Is it x squared minus y squared?
Yeah.
Over
Oh,
x
wait,
squared
is it like
over
that?
36 minus y squared over 16 equals 1.
Yeah.
Okay. Here we go. This equation pops up. X squared over 36 minus y squared over 16 equals 1. First thing in your brain needs to go, that's a hyperbola. How do you know?
Because it has a negative.
It has the negative. It's not an ellipse. Here's one thing. If I put this right there, what is it?
It's a
Ellipse.
Definitely an ellipse. Make it a minus, definitely a hyperbola. Now, this one is centered. Notice x squared and y squared don't have a parenthesis, so this hyperbola is going to be centered. So I'm going to draw it. Here's the center of it. Now, on this first example only, I'm going to draw it. I'm going to do the exact long way that if you went on YouTube and watched any video of them doing it, they're going to draw this box and be really sophisticated. After this one example, we're going to go like quick hand, basic, how to get the right answer. So the first thing is, it's left and right. So the first thing you go and look at the 36 under it. 36 is what times what?
6.
6 times 6. And then the y is 16. 4 by 4. The second one that you're minusing is less important. And when we kind of just go basic, we're not going to use it. But what you're supposed to do is go 6 by 6 to the left and right. And since it's a left and right hyperbola, those are the vertices of that parabola. Now, if you want to get the exact shape, this changes the shape. That 16 means go up 4 and down 4. And you kind of make a box, so I'm going to just kind of do it dotted. If you see these little dotted lines in your answer, understand that that's just kind of part of the process. And then they put diagonals through the box. Usually those are dotted as well. And your little sideways parabola things, they're supposed to just kind of go up next to those lines. Like that. No. What I'm saying is this is how you make the actual shape. The biggest thing to know is if you know your hyperbola goes left and right, if the number under here is 36, find your center, go 6 this way and 6 this way. That's why I've got my 6 this way and 6 this way. When you look at your multiple choice answers, could you have figured this out just knowing that the vertices are 6 apart? Yeah, because one of them has them 6 apart and the other one has them what? Like 4 apart. So that was it. All right. So let's look at the second example. Again, the second example is centered as well. In that second example, does it start out with y squared?
Yes. 16y squared minus 4x squared
Minus
minus
64.
64.
Okay, so we don't, all right, 16y squared minus 4x squared,
Minus 64.
oh, minus 64, equals 0. Here's what we need to do.
Get the
Now,
number to the right.
If you're working a worksheet and it's all hyperbolas, you probably know you're looking at a hyperbola. What you need to think though is if you're doing like an end of the year test or if you're doing an ACT, how do we know that this shape is going to be a hyperbola?
Because it has a
Because of the minus. You have x squared and y squared, which means 3 things. If x squared and y are squared, it's a circle, it's an ellipse, it's a hyperbola. But because of the minus, it's definitely a hyperbola. So here's what you want. We want a 1 over on that side. So first thing is add the 64 over. So let's
Okay,
add
so
that
why
over.
would this not? Oh, okay, never mind. Never mind. I got
So
it.
add the 64 over. So we have 16y squared minus 4x squared equals
64. Then you have to divide
64.
by 64.
Yeah. Let me put the note right here. Just like an ellipse, circle's not like this, but just like an ellipse, hyperbolas want this number to be 1. We want a 1 on the right side. So if I have a 64 on the right side and I want a 1, what do I got to do?
You have to divide by 64
Yeah.
on all of them.
All things get divided by 64. Cross this out. Now this equals 1. Now I need to reduce 16 over 64 makes 1 over 4. So this becomes y squared
And then
over 4
negative
minus
x
4
squared over 14 or 16.
x squared over 16 because 4 over 64 makes 16. And here we go. That's what I want to graph right there. Notice one thing. Do you see the coefficient was, the coefficient on the y was 16? And it's kind of like it went under the x. And then the coefficient on the x was a 4. It's kind of like it went under the y. That happens a lot when you go dividing all these things by 64. So keep that in mind. It's just like they went, like this went that way and this went that way. All right, so let's graph it. First question. It's a hyperbola, we established. Is it a left-right hyperbola or an up-down hyperbola? Up-down, because
Y.
Y squared.
yeah, y squared minus x squared. So look under the y. This is the key to find the vertices. It's centered. I know that. It's centered. This number, 4, means what by what?
2 by 2.
That's what I want to go, but I'm going to go up 2 and down 2. So this is 2 by 2. I'm going to go up 2, down 2. And what I mean by basic is I know the vertices and I know which way they should go. One's going up, one's going down. Like that. Can you establish, we're using them like multiple choice elimination, which ones have vertices up 2 and down 2? Even if it doesn't look like that, because I'm just being basic about it. It's, which one is it? C, right? The other one has the vertices up too high, then that's
Yeah.
that one. Okay, for example 3. I'm going to take it back over to the other board. All right, I'm going to give you this and ask for the equation. Now, it's definitely a hyperbola, but would you say this opens left or right or up and down?
Up and down.
Up and down. So if it opens up and down, what does that mean as far as your x's and y's?
Y is going to be first.
Y is first. Y squared minus x squared. So I'd look at your 4 answers. How many say y squared minus x squared? 2 of them have y squared minus x squared. So it has to be one of these two. So we're going to take one of them and put them into the right form for graphing. Which one do you want to take?
B.
Take B? Okay, let's take B. If it's not B, it's going to have to be D. So go ahead and write B up here so we can fix it. B is 36y squared minus 9x squared minus 324 equals 0. And since we know it's B or D, if it's not B, it's going to be D. All right, hyperbola. First thing, I want a 1 over there on the right. Get that number, that's negative 324, get that over there on the right side. So it's going to be 36y squared minus 9x squared equals 324. And this is not a circle. I don't want a number over here other than 1. So how do I get that 1?
Divided by 324.
Divide by 324. And just like we said before, what happens is basically this 9 comes under the y, this 36 goes under the x. If you reduce this fraction, it becomes 1 over 9. Reduce this fraction, it becomes 1 over 36, not 1 over x squared over 36. Is this what you want? Do you want a 9 under that y squared? No, we don't want a 9. Because a 9 means 3 by 3, right? And so do I go up 3? That's not it. It's not up 3, down 3, it's up 6. What did I want under there?
33.
I wanted 36. So it's actually going to be D that gets you that 36 that you want. Remember one thing, as you work it out, if the coefficients are up here with the letter, a lot of time they switch when they go down. Like the 36 under the y squared and the 9 would go into the x squared as you work it out. So that's why we end up having, and we'll save time by just understanding that's got to be it. The reason I put those dotted lines the first time, not that they mean anything other than kind of the shape, but if you see the dotted lines, don't let them freak you out. The dotted lines are just kind of in there because of the shape. Does this thing open left or right or up and down? Left and right. A hyperbola that opens left or right starts with what?
X.
X squared minus y squared. How many answers do you have that have x squared minus y squared?
2.
A and C. A and C. Now, when it comes to A and C, there's one of them that's like a little bit better to start with, to check out. Which one?
C.
C's in like the check it out form. It's like x squared minus y squared and the numbers are under it. What does that 9 mean? 3 by 3. And since it's a left-right one, if you went left 3 and right 3, do you have the vertices?
Yep.
Yeah. Left 3 and right 3. So that's it. It's going to be C. Imagine if you worked this one out. You want that 9 under the x squared. When you work this one out, the 25 ends up under the x squared and the 9 ends up under the y squared. All right, we have one example. Out of all of this, we have one example only where the center is not the origin. So pay careful attention. This is probably the hardest one we're going to look at right here. The center is not always the origin. Sometimes the center is kind of over here in the third quadrant. Now, naturally, first thing I'm going to do is say I'm looking at a hyperbola. Does it open left or right or up and down? Left and right, which means what minus what?
X squared minus y squared.
X squared minus y squared. Does that help you at all? No, because they all your answers start out x squared minus y squared. So what we got to do is find the center of this. Now to find the center, take your pencil and let's put it on the vertice of this one, which is right here. Just put it on that vertice. You should be able to go straight left, count the dots to get you all the way over here. So if you're right here, let's count to get over to the other one. 1, 2, 3, 4. If you want the center, go back halfway. 1, 2. So this is 4 across, so go back 2, and that's the center. You might mark it on your paper. Right there. Okay, now what are the coordinates of that center? Let's write them, go ahead and write them right here.
-3.
-3.
And down 5.
Down 1, 4. -3, -4 is the center. Now remember how you move these shapes? If your center is -3, -4, put the -3 in with the x, but opposite. So I want to see an x plus 3, and then since you're putting this in a parenthesis with the y, I want to see a y plus 4. So how many options do you have where you have an x plus 3 and a y plus 4? Just one. X plus 3 and a y plus 4. Also notice what is underneath the x? 4, which means 2 by 2. Remember how you had it's 2 across? So that's what we have. 2 by 2. And the very last one I got is back to being centered. Like I said, that was the only one you have with the center is not the origin. Here the center is the origin. Is this going to be an x squared minus y squared or y squared minus x squared?
X squared minus y squared.
Yeah. So how many do you have that say x squared minus y squared? 2. So it's I crossed one out, but I want to. It's B and C. Now, what's the distance from the center to the vertex right here? 3. So what do you want under your x?
9.
9. Now let's think about it, because none of them are set up right. Well, let's look at B first, because B is the wrong answer.
It'll be 9.
Yeah.
It'll be 1, 9.
If you did this one, the 36 ends up under the x, and the 9 ends up under the y. So you want to do C, because when you work the C out, this 9 ends up under the x, and the 36 ends up under the y. And so that's it. Hyperbole is not in there. All right, remember the 4 conic sections. The parabola, the circle, the ellipse, and the hyperbola. If you're a parabola, you will have an x and a y, but only one will be squared. And that's a U shape. If you're a circle or an ellipse or a hyperbola, you will have x squared and y squared. It's easy to tell which is going to be a hyperbola because of what?
It has a negative.
Because one of them is negative. Now, when you have a circle, your x squared and y squared should be the same. Like your coefficient that goes with it. So let's look at the very first one. I got 3x squared plus 3y equals 2.
Parabola.
It's trying to trick you into thinking it's a circle. But it's a parabola because yeah, you can resolve this into y equals something with an x squared. So that's parabola. All right, the second one, x squared over 3, y squared over 16, and 1.
Ellipse.
Why is it an ellipse and not a circle?
Because it has the 1.
It has the 1 over there, and underneath it, we've got different numbers. So we don't have an ellipse. All right, 3x squared, 3y squared, and 16, circle. X squared and y squared are positive, and the coefficients next to them are the same, so I could divide them all by 3, and there won't be coefficients. 5x squared minus 4y squared is 21.
Hyperbola.
Hyperbola. Easy to see because
The negative.
the negative, and they're both x squared and y squared. You got them both squared and a negative. All right, 2x plus y squared over 4 equals 2.
Parabola.
Parabola. Why can we tell it's a parabola?
Because it's 1 squared.
Yeah, because the y squared, the x isn't squared. I saw this it's probably been like 3 years. One of the trickiest things that I've seen an EOI try to do. After teaching you all about how these things look, somebody did this. They went x squared over 5 minus y over 16. They probably even did nice numbers where you'd think it was. That looks an awful lot like a hyperbola. But why is it? But
Because it doesn't have
It's
a
a
y
square.
squared.
Yeah. If it doesn't have a y squared, then it has to be a parabola. That's a hyperbola. And of course,